Hello everyone. Basic electronics is a subject included in second semester and branch first semester BE students for all the branches. The basic electronics includes 5 modules, out of which we'll be doing with the first module, that is semiconductor diodes and its applications. Before going into the first module, let us look into the syllabus. This is going to consist of 5 modules. First one is the semiconductor diodes and its applications, where it speaks about the p-n junction diodes, its equivalent circuits, and its applications. The second module tells us the FET, about the FETs and SCRs. And the third module tells us about the operational amplifiers and applications. The fourth module tells us the BJT applications, feedback amplifiers, and oscillators. The fifth module speaks about the digital electronics and fundamentals. These are the course outcomes for the basic electronics subject. First course outcome is going to describe you the operation of diodes, BJT, FET, and SCR. And the second, it is going to explain the construction and working of rectifiers, regulators, amplifiers, and oscillators. Third, it is going to explain the working of operational amplifiers and its applications. Fourth, it is going to explain the different number systems and their conversion and construct simple and combinational sequential circuits. We are going to look into, in the first class, let us look into the p-n junction diode. There are two types of semiconductors. One is the p-type semiconductor and the other one is a n-type semiconductor. The p-type semiconductor is going to have the majority charge carriers as holes, which are positively charged, and the n-type semiconductors have the electrons as the majority charge carriers, which are negatively charged. When both the regions are sandwiched together, the holes have the tendency to move across the n region and the electrons have the tendency to move towards the p region. As a result, a region is formed where the electrons and holes starts depleting, and this region we call it as depletion region. The holes and the electrons which are in this depletion, which have left their respective regions and entered into the depletion region, are not called electrons and holes. They are called as positive ions and negative ions. Moving on to the next concept, we are going to study the biasing conditions of p-n junction in two forms. One is the forward bias condition and the second one is the reverse bias condition. In the forward bias condition, the P region is going to get connected to positive and the N region is going to get connected to negative. The logical symbol of the diode is represented by a plate, which we call it as a cathode, and the arrow indication says it is a anode. Once the P region is going to get connected to positive and the N region is getting connected to negative, we say it as a forward bias condition. We have a characteristic or the property that like poles ripple. As a result, the electrons in the N region move apart from the external bias applied and the holes in the P region move apart from the external supply that is applied. As a result, the depletion region is going to narrow down. Now, due to this, since there is a movement of electron and hole pairs, I can say there is a flow of current, and that current we call it as forward current, which is represented by ID, or IF, which is represented by ID, or it is also called IF. Now, the current which is due to this current is constituted mainly due to the majority charge carriers. When we plot the characteristic curve of current versus voltage, I can say there is a till it reaches the threshold voltage, it is approximately zero current. Once it reaches the threshold voltage, there is a forward current. So the threshold voltage for the silicon is 0.7 and for the germanium is 0.3. This is about the forward bias characteristic. In the forward bias characteristic, mainly it is the diode is going to conduct and it is going to act as a closed switch, and there is a flow of current due to the majority charge carriers. When we go for the reverse bias characteristic, we can see the P region is getting connected to the negative terminal and the N region is getting connected to the positive terminal. We have the property saying that unlike charges attract each other. The holes that are present in the P region have a tendency to move across the negative terminal, which is connected as an external bias, and neutralize themselves, and whatever the electrons that is present here have a tendency to move towards neutralize with the positive terminal of the external bias. As a result, the depletion region is going to widen. The width of the depletion region is going to get widened, and there is a point where the majority charge carriers or all the majority charge carriers that is present in the P region and the N region are going to get neutralized, and it is only left with the minority charge carriers. As and when we increase the reverse voltage that is applied, the minority charge carriers that is present here in both the regions will constitute a sudden rise in the current, which we call it as a reverse saturation current. When we plot a characteristic curve of V versus I can say till it reaches the breakdown voltage, the voltage where there is a sudden rise in the current, we call that voltage as a breakdown voltage, and that current we call it as a reverse saturation current. The final gist of biasing, that is VI characteristic of a PN junction, is nothing but in the forward bias the diode is going to conduct, and in the reverse bias the diode is going to not conduct. It is going to act as a open switch. Let us study with the relation between the voltage and current through the PN junction. The current equation, the current and voltage relation between as discussed, ID represents the forward current or the diode current, which is equal to Is into e to the power of k Vd by Tk minus 1, where Id is nothing but the current through the diode, which we call it as a forward current or a diode current. Vd is nothing but the voltage across the junction, and Is is nothing but the reverse saturation current. Tk is nothing but the temperature in degree Kelvin. So no matter whatever might be the temperature, add plus 273 to that becomes degree Kelvin, and K is nothing but the Planck's constant given by 11,600 divided by eta, where eta is equal to 1 for germanium and 2 for silicon. So this is what is the relationship between the voltage and current through the PN junction. So we already studied what is a breakdown, what is a breakdown voltage. Now, as and when we increase the reverse voltage, more and more holes and electrons get neutralized. The majority charge carriers are going to get neutralized, and it is only left with the minority charge carriers, which will constitute a reverse saturation current, and that voltage we call it as a breakdown voltage. So as and when further we increase the reverse voltage, there is a possibility of device getting damaged, and that point we call it as breakdown, and that point we call it as breakdown. There are two kinds of breakdowns going to occur. One is a Zener breakdown and the other one is a avalanche breakdown. Zener breakdown is caused due to the strong electric field in the depletion region, whereas the avalanche breakdown is going to be caused due to this is going to occur in the wider depletion region. Totally, in a gist, when we look into the VI characteristic of PN junction diode and we plot a graph of VI characteristic for the forward characteristic till it reaches the threshold voltage, there will be no current constituted. Once it reaches the threshold voltage, the forward current is constituted. It is 0.7. Threshold voltage Vt would be equal to 0.7 for silicon and 0.3 for germanium. In the reverse bias condition, when the diode is in the reverse bias condition, it is not going to conduct. It acts as an open switch till the breakdown voltage. There will be zero current, and when it reaches the breakdown voltage, there is a sudden rise in the current, and that current we call it as a reverse saturation current, and that region we are going to call it as either a Zener breakdown region or an avalanche breakdown region. Coming to the equivalent circuit of diode. Equivalent circuit is nothing but it is a proper combination of circuit elements like voltage sources, current sources, resistances, etc. to represent the best actual terminal characteristics of a diode or a device. Okay, so here we are going to study the equivalent circuit of a diode, which is in three forms. One is three models. One is ideal model, other one is the approximate model, and the other one is the piecewise linear model. In the ideal model, we are going to consider the diode in the ideal condition where the current is equal to 0 and the voltage is equal to 0. At this condition, the diode is going to act normally, that is without any threshold voltage or anything applied, or that is at the ideal condition. This is going to act as a closed switch as well as a open switch. Moving on to the approximate model. In the approximate model, when the diode is going to be applied, that is the name itself suggests there is an approximation. Yes, there is an approximation in terms of current and voltage. As a result, my diode can be replaced with a threshold voltage, which we call it as Vt. So my diode is going to act as a closed switch as well as an open switch with the help along with the Vt voltage in the approximate model. In the piecewise linear model, in this approximation, both along with the threshold voltage, we have a dynamic resistance present here. So it is represented with the help of Vt along with the dynamic resistance Rd, and it is as shown in the here.